Welcome back. I'm glad you made it this far, because this is where we're going to review the exciting stuff. We're going to take a look at the overall implementation of the project, how everything fits together. We'll review the finer design details, and also how Amazon could make our life easier with skill development. So I hope this will help you to understand the overall project, and I hope that the lessons learned will also help you with any future skill development in general. Let's do this. During the installation, you saw that we created a custom skill and not a smart home skill. And that is simply because Amazon does not have smart home skill support for remote control. There is no voice model for that. So we really don't have a choice other than using a custom skill. But that means that the user has to invoke our skill with the skill name. They have to say something like, Alexa, tell skill name, and then the command, which makes the command much longer, much more awkward, and especially with something that has so many small commands like our remote control commands, that can very quickly become quite annoying. To get around this problem, we heavily rely on sessions, and we're also playing a little trick on how we invoke our skill. We'll take a look at that shortly, but let's start out with a general overview of our voice model with the intents and slots in there, and at our Lambda handler. The voice model is defined in the Alexa folder, in the subfolder models, and is in the en-us.json file. No surprises in this file. We define two main intents here. The first one is the press remote button intent, and it allows the user to specify the button they want to press. And optionally, we also support a press count. So the user can press a button multiple times by saying something like press right 3 times. The second important intent is the switch TV source intent, and that allows the user to switch between devices. So the argument that this intent takes is the actual device that the user wants to switch to. In addition, we have one third intent here that you will see. That's the press 2 remote buttons intent, and this allows the user to just press 2 buttons in succession. So like press right and down, so they don't have to say press twice. This is really just a specialization of the remote buttons intent to make things a little bit more user-friendly. Below the intents, you have the definition of the slot values, the list of remote buttons, and the list of TV sources. And we already discussed this in detail during the installation when you worked on the configuration. Now, when the user invokes an intent, Alexa gathers the slot values that were specified and passes them on to our Lambda function. That's where the actual skill execution happens. And all of this is just using the standard Alexa SDK functionality for handlers. We have our handler definition here at the top. And we then configure our handlers for the various intents. We have 2 main handlers, the press remote buttons and the switch TV source handler. Press remote buttons is capable of executing multiple buttons, so it's taking in an array of button commands, and it's simply looping through that array here and passing on control to press remote button. Press remote button then in turn goes through all the execution details, through the various error conditions, and if everything works out, it ultimately winds its way down to the send command. And this routine is responsible for sending the actual REST API call. And similarly, we have the switch TV source handler, which is a little bit simpler, and it also then eventually calls send command to invoke the REST API call to switch a device. Now let's dig a little deeper into session handling. As mentioned earlier, for ease of use, we want to invoke our skill only once. And then we want to send all of our button commands within the session and without having to invoke the skill again. Now, typically, we have to create a special intent to create such a session. Something like, Alexa, tell remote control to start session. Now, that is pretty unintuitive because the user doesn't think in terms of starting a session. They just want to issue their commands. So we're using a little trick here because it's entirely valid to just invoke the skill by name without any intent. So the user is allowed to say, Alexa, remote control. And when we look at our handlers here, this is where the SDK is passing us the different intent handlers, stop intent, cancel intent for the defaults, then we can respond to that. But it's also passing a special case called unhandled. And unhandled is passed to us whenever Alexa cannot determine the actual intent invoked. And a special case of that is when the user just says Alexa remote control. We end up receiving unhandled, simply hook into that, and start our session then in response to that. So this makes for a very concise way of kicking off our session. If you're curious where this unhandled event is actually coming from, feel free to track it down into the Alexa SDK. Remember that we had to download the Alexa SDK as a package dependency when we did the npm install in the beginning. So just go to the Alexa folder, custom subfolder, and then our dependencies go into the node modules, and under that Alexa SDK lib, Alexa.js is the specific file here. And in the emit event function, they simply look at the case where an intent is not understood. They generate an unhandled event string and then pass that, emit this event string onto us. And that's where we can handle it. So no magic where this is coming from. By the way, if you want to change the skill name, simply head back over to the voice model. And at the beginning, we have the invocation name. So if you want the user to use something other than Alexa remote control to kick off the session, just change this string here. Now let's get back to our start session functionality. The main piece is that we invoke the start session function. And in here, we first start out by setting our state. This is how we establish the session. So we're telling Alexa that we're now in the press remote button mode. And all of our subsequent intent handlers are registered under that state. As you can see here, we created all of our other intents under that state. We did not create those under the general handlers that are invoked without a session. So this is all the basic Alexa SDK functionality for session handling. TV source is the most important attribute that we maintain. In this attribute, we store the device that is receiving our button commands. And we initialize this value to whatever was specified in the configuration data. Now you might remember that we are also sending a mute command when we start a session. And this was done so that the volume of the TV doesn't interfere with any future session commands. And that is happening here. So we're doing a send command, issuing the TV mute command to the TV. And then all we need to do to wrap up things is to have Alexa say that she is ready to start the session. Now that we have our session going, the user can start using any of these session intents. And the main ones are press remote button intent, press 2 remote buttons intent, and the switch TV source intent. What is left now is to end the session. And the user simply does that by saying done. Done is implemented for simplicity as a special button and is then handled in the press remote button routine as a special case to end the session. It would have been a little cleaner to introduce a separate done intent to do that. And this is where we can then call end session. And in end session, all we have to do is issue another command to unmute the TV again. This works great if the user does end their session by saying done, but what if they don't? Then they are left with a muted TV and will not be happy about that. The Alexa SDK injects another event called session ended request into the framework whenever a user simply lets a session expire. So it's important for us to answer that event as well, and all we need to do is call end session. Note that we are not allowed to have any verbal responses here from Alexa. We can only issue commands. So we cannot state that we are actually ending the session for the user, but we can issue that unmute command on the TV. To the user, it looks like this. Note how the TV is automatically unmuted at the end of the session. Alexa, remote control.
Okay, ready.
Menu.
Okay.
Next up, let's drill into press remote button a bit more. The first interesting piece that's happening here is the slot function. This is pretty subtle, but very important. Now remember that we specified the slot values in the voice model. And we specifically wanted to allow the user to refer to a button by its main value, like OK, but also by synonyms, like enter or select. Now it's important to understand that when Alexa matches an intent, such as our press remote button intent, which requires a remote button, there is no guarantee that the remote button slot value presented to us is one of the valid choices below. Alexa may determine that the overall intent was press remote button intent, even though the actual remote button value is not in the list of the slot values. So we have to be prepared to validate the slot value against the list of our actually expected slot values. And then if the value actually is a valid slot value, then we have to map the value back to the ID so that we know which unique ID we have to process. And that is what our slot method accomplishes. So in the slot method, we have to first establish that there was a match in the first place. And if there was, then we have to pick the correct ID for our result value. And if we didn't get a clean slot, then we will return null. Amazon calls this slotting mechanism entity resolution. So if you're curious about more details, just search for entity resolution and you'll find a lot more information. I wish there was a flag in the voice model that I could require an intent to have an exact slot match. That would simplify my intent processing because I can assume there is a valid slot ID and I don't have to do any manual slotting. That seems like a good future feature because the vast majority of use cases do require exact slot matching. Once we have a valid remote button result from the slotting, then we can proceed to get our device-specific command. And this is what getDevice command for button can do for us. We're giving it the device that we want to send it to. And remember that we're keeping that device in the session. So we're pulling that out of the session. And the button that we want to execute is the one we just slotted. GetDevice command for button is straightforward then. It simply uses the buttons map that we specified in our config data to do the mapping. Now, if device command for button comes back as undefined, then that means the button is not supported by the current device, and we have to report that as a clear error to the user. We indicate to them which button was not understood, as well as which device could not handle it, so that the user clearly understands what happened and can correct the situation. And if device command for button is valid, then we can go ahead and proceed with issuing our send command. We do this in a loop because we support the notion of press count. Note that press count is also a slot value, but it's an integer value. So it can come in as undefined or as null, in which case we simply treat it as a 1, or it comes in as a correct integer value. We don't have to go through the full slotting mechanism using entity resolution as we had to go for the remote button itself. Also note that there is a second error condition at the bottom where we again report that the button is not supported by the current device. But this situation is slightly different from the above case. Above, we had a valid button, but then we couldn't find that button in the button command map for the current device. However, in this bottom case, we can't find the button in the first place. It's not a valid global button at all. To the user, it's really the same thing, and that's why we report the same error. But underlying, there are two different error cases. So why are we finding ourselves in this situation? It's because we have to define a global list of buttons in the voice model. And then we have to validate the buttons through the button map to see what device supports what. And that's really not too bad, right? Implementing getDevice command for button was not a complex thing. However, if we could give a hint to Alexa and say, hey Alexa, for the next intent, we are currently working actively on device X, and therefore we know the user will only issue one of the following N commands, as opposed to the whole global list of all possible commands. That could drastically improve the voice accuracy for Alexa. Again, sounds like a neat future feature, and I'm sure the Alexa team is already working on dynamic voice models. Take a quick look at Switch TV Source. This function is very similar in flow. We start out by slotting the TV source slot. We then put, if everything goes well, the device into the session under TV source so that future commands can all go to the new device. And then we proceed to issue the send command to actually make the input switch on the TV. And if something goes wrong, we again give a very detailed error message to the user so they understand what happened and how they can correct it. To wrap things up, let's take a deeper look at how we're sending commands and how we are issuing responses to the user. The flow is always the same. We are sending one or more REST API calls, followed by a final emit of a response through Alexa. No surprises in send command. It's basically deferring the work to call web service, and call web service then manages the specific HTTP call. The emit function then handles the voice response through Alexa. This is a simple utility over the Alexa emit function. As you can see, we pick ask mode if a response string and a repeat string are specified. And in that ask mode, Alexa asks for input and keeps the session open. And Alexa will re-ask again if the user doesn't respond using the repeat string. Unfortunately, the Alexa framework currently doesn't allow us to configure how long it takes until Alexa reprompts the user with the repeat string. For our remote control commands, we would like to give the user a little bit more time before they are prompted to issue their next command. So we use a little hack here. We defined an empty string Alexa empty reprompt, and in press remote buttons, we are using this empty reprompt as our repeat string. So after a button press, Alexa responds with OK, but then does not reprompt while it's waiting for another command. So since there is no reprompting, it feels to the user as if they have twice the amount of time to respond with the follow-up command. A little hack to extend the response time at the cost of losing the reprompt. Of course, what I would like to see is a configurable wait time and reprompt time in the framework. And again, I'm sure a feature that the Alexa team is already working on. The most interesting part about send command and emit is probably the processing flow. So first of all, we have to recognize that send command needs to be an asynchronous activity. Send command is calling the REST API, it's making the HTTP call, it has to wait for the execution and then get the result back. We don't want to synchronously wait for that. So send command definitely has to be asynchronous. But we have two limitations for the execution order of send command and emit. Limitation number one is that multiple send commands must be executed in the order that we received them in. It would be nice if we could just fire all the send commands in parallel, that would be easy, but we have to honor the original order. Imagine the user submitted press menu and 3 times right. That could have a very different result from moving right first, then menu, and then right 2 more times. So send command number 2 cannot start until send command number 1 has finished. And there is a second limitation. Emit, which is providing the final voice response to Alexa, must execute at the very end. Why is that? When emit finishes, it kills the entire Node.js environment that our Lambda function is executing in. So nothing can execute after the emit function. So putting all of that together means we have to execute our send commands in order, followed by a final emit call. And how can we accomplish that? Through futures and promises, which are provided by Node.js. We simply pass a promise into send command, and on the first call that would be null, and when it's time for execution, we follow the command promise equals null path and call the call web service. Now call web service is executing asynchronously and is returning a promise, and then we are returning this promise to the caller of send command. The caller of send command will then pass this command promise into future calls of send command. So any additional invocations of send command will go into this path, and at that point we will chain the execution of the next call web service invocation behind the initial promise and return a new promise for that chained execution. So with each additional call of send command, we are simply chaining more and more of those promises, and all of the actual call web service invocations are then guaranteed to execute sequentially. And we use the same mechanism for emit then. We're passing in the promise, and if the promise is defined, then we are chaining the call of the Alexa emit behind that promise as well. So this way emit will always line up behind all these send command invocations. And of course, in cases where we don't have any send commands, then command promise would come in as null, and we could directly execute Alexa emit without waiting for anything else. I wanted to point out one more detail regarding the voice model. In the press remote button intent, we specify through the samples how the user can invoke this intent. We saw this before. And we give the user multiple options. For example, they can say write, or they can say press write. And optionally, we let them express a press count if they want to press a button multiple times. And they can say that in different ways. They can say write 3 times, or they can say write 3, or they can put the count in front. 3 times write, 3 write. Nothing surprising here, we just want to make it user-friendly, that the user can express what they want to accomplish in different ways. Now things get tricky when we move on to the press 2 remote buttons intent. For efficiency, we want to let the user express 2 commands in one invocation, such as write and down. We want to let all the permutations that we allowed just above for the first command, and then allow all the permutations for the second command that we defined above. Unfortunately, in the voice model, there's no way to refer back to the voice model that we previously defined and say it's the permutation of those 2. Instead, we really have to spell out all those permutations manually ourselves here. And that's how we end up with this long list, which is very error-prone to type and very cumbersome. And if you look closely, these actually are not all the permutations of the above values. For example, all the presses are missing. Within the 2 command invocation, the user cannot use the word press. Imagine how long this list will blow up if you introduce press as an option in all permutations as well. What this means for the user is that the 1 and the 2 button commands are not consistent, and that's unintuitive. And if you want to add support for more commands within one invocation, such as guide and write and down, this problem will only become more pronounced. What would be really neat if we could express our voice model in terms of blocks of previous models. And as before, I'm sure that's already on Amazon's roadmap for Alexa. To close out our tour of the project, there are only 2 files left that we haven't looked at yet. Under the Alexa folder, in the Lambda custom subfolder, there's a file package.json. And this file simply specifies the dependencies for our Lambda package. And that dependency is the Alexa SDK. And similarly, there is a JSON file under the remote control folder called skill.json. This file follows Alexa's format to define a skill and simply defines global attributes for our skill. And last but not least, the .ask folder is maintained by the Ask CLI tool that we used earlier to create our skill. And the CLI uses that folder to manage its state. The only other files we haven't talked about are the OpenHAP files, the .items and the .things file. We have discussed these files during the setup, and the beauty of OpenHAP is that we really don't need to do anything other than that setup configuration. From there, OpenHAP takes care of everything from providing the REST API interface on each item, passing the command to the item, passing it into the channel defined in the things, and passing it into the Harmony Hub from there. By the way, did you notice the Easter egg about winding? If the user is actively winding forwards or backwards and then is pressing a button other than play, pause, or stop, then Alexa automatically inserts a play button to avoid runaway winding. It looks like this. Notice how the play command is inserted automatically at the end. Alexa, remote control.
Okay, ready.
Fast forward 3 times.
Okay.
Menu.
Okay.
And that's it. I hope you found this guided tour of the implementation useful and that the lessons learned will also help you with any of your future skill development. And there are obviously tons of things that can be improved in this project, so I would love to hear about your ideas or see your contributions.